Students, in the last video we saw about the Kohlraush law and how was that formula derived. Okay, in this video you are going to see the applications of Kohlraush law. Okay, how to find out that how to write down the applications. What are the applications? First let us go and then we derive that applications also. Okay, so first of all we just go with the formula. What was that Kohlraush formula? Okay, it was given by Kohlraush. The formula was given by Kohlraush, so we let us go with that. Lambda m infinity is equal to lambda m naught, or else we could say that lambda m naught, or we can otherwise called limiting molar conductance also, is equal to V plus into lambda m plus V minus into lambda m minus. What is that V plus and V minus? It is nothing but number of cations and number of anions. When you have a dissociation, definitely you will have number of cations and number of anions. So that has to be written first. First of all, we will go with the cations and its molar conductance has to be multiplied. And then you need to sum it up. You have to add it up. Then you go with the cations, number of cations into its molar conductance. So it is actually the sum of the cations multiplied with its conductance and anions multiplied with its conductance. Okay, this is the formula. So by applying that formula, we can get that lambda m infinity of electrolytes. Strong electrolytes can be easily got, but for weak electrolyte it is not possible. Why? Because actually he gave a graph, right? By graphical method it was not found out. We were not able to find out actually. What is that graphical method? See, he plotted a graph against concentration and lambda m, okay, molar conductance. In that case, he got a graph of, for a strong electrolyte KCl, he got a linear line, whereas for acetic acid it was a curve. Linear line means what happened? The molar conductance get increased when the concentration is decreased. So going back, okay, I like that when the molar conductance is increased for acetic acid also when the concentration is decreased. See the way for KCl it is a line, straight line only. We can extend it and it can be made to meet at y-axis. So that y-axis point is going to be lambda m infinity, or else you can say limiting molar conductance. Okay, whereas limiting molar conductance is the value point at that the molar conductance stops. Okay, remember that. Okay, then for acetic acid it is not going to, see that the curve is not at all meeting at in the y-axis, so it's not possible to find out its lambda m infinity. So we can go by the formula application. So graphical method tells you that it is not possible. Now for that only we are applying the formula. Even that formula, if it is going to be like this, for example, acetic acid, you are just applying that CH3COOH, it gives you CH3COO minus plus H plus. This is what acetic acid is, a weak electrolyte. So we are going to determine the lambda m infinity for a weak electrolyte only, isn't it? This is what we are going to do. Example, you are taking acetic acid. When it gets split up, you get these two ions. The number of ions is going to be 1 only. Applying the Kohlraush law, we apply the Kohlraush law here. Lambda m infinity, because this is going to be 1. I'll just leave that V plus and V minus over here. Okay, that is V plus and V minus, whatever it is, number of cation and anion is going to be 1 only. So just we leave it off. And then what you get the answer? It is going to be lambda m infinity is equal to lambda m H plus lambda m CH3COO minus infinity. Okay. If the values are given in the calculation, you can just add it up and you can find out. Actually, the value is for H plus is 349.8 and for that is molar conductance of the H plus ion, okay, at infinity, and lambda m, there is a molar conductance of acetate ion is 390.7. So when you, it is 40.9. So what happened? You are going to add it up both. When you add up both, you get the 390.7 Siemens centimeter square, cm square and mole inverse. Okay, cm square and mole inverse. This is the answer, you get it up. Okay, but if the value is going to be in this way, it is okay. Then if or else what happened? We can go in another way. You can find out using that common ion effect. We used to say that using the common ion effect, we can find out the answer. What is that common ion effect? Let me go with it. See, let us take molar conductance. We are going to find out the molar conductance of three different things. What is that? One, you go with HCl, another one sodium acetate and NaCl. Take down all these three. Okay, three of their conductance. Now here no acetic acid. We do not know the, we are going to find out the acetic acid only. Finding out the molar conductance of acetic acid. Okay, for that we are taking HCl, CH3COONA and NaCl. Why? Because we are taking that whichever is common in these both and we are subtracting it from that. Okay, it is a common ion effect, we used to say, removing that common ion. Right, let us go with that HCl first. Lambda m infinity of HCl is equal to lambda H plus infinity plus lambda Cl minus infinity. Okay, like that, lambda m infinity of CH3COONA, okay, is equal to lambda CH3COO infinity plus lambda Na plus infinity. Okay, like that, lambda m NaCl is going to be lambda Na plus infinity plus lambda Cl minus infinity. This is what we are getting. Now what we are going to do actually, we are going to add it up these two. Okay, and then we are going to, from that we are going to subtract this last one. So the HCl and these two are going to be added up and this is going to be subtracted. So I just put it down in this way. What is that? Lambda m HCl infinity plus lambda m CH3COO minus infinity. Lambda m HCl infinity plus lambda m infinity CH3COO Na minus of lambda m infinity NaCl. Now I bring down these, whatever that we derived for that lambda m HCl, whatever the values you got it here, no, just bring it over here. So bring down that values and put it down like this. What do you get? Lambda h plus infinity plus, I just bring down this here. Okay, lambda h plus here, this value here, this value here, this value here. Okay, so I just write it down like this. Lambda h plus infinity plus lambda Cl minus infinity plus lambda CH3COO infinity plus lambda Na plus infinity minus of okay, minus of lambda Na plus infinity. Why minus? I have put sign, no, so it becomes minus of minus, it becomes minus over here. Okay, lambda Na plus infinity, this plus will become minus into plus minus. Okay, so minus of lambda infinity, lambda Cl infinity. What I do, I'm just I have striken and kept for you. See, this Cl is minus, this Cl is minus Cl. Okay, and with this, okay, cancelled. Like that, this is minus of Na plus and this is plus of Na plus. Both get cancelled. So what is left here? Only we got lambda h plus infinity and plus lambda CH3COO minus infinity. That means you are getting only for acetic acid. So at last we got it. Lambda m CH3COOH is equal to lambda h plus infinity plus lambda CH3COO minus infinity. So the addition of these two will give you the value of lambda m acetic acid. Is it clear? So with this, what is that derivation, we can go find out the weak electrolyte at infinity, the molar conductance at infinity. Okay, at infinite dilution, what is its molar conductance for a weak electrolyte? This is the first application. Now let us go with the second application. Actually, second application goes with the degree of dissociation. Okay, so we are going to find out the degree of dissociation. So second one is determination of degree of dissociation of weak electrolyte. This weak electrolyte degree of dissociation is always written as alpha, remember. Okay, this is at concentration. At whatever the concentration you want to write, you can write. So lambda, this is not lambda, this is actually alpha. Alpha is nothing but degree of dissociation. So degree of dissociation at concentration C. At concentration C level is equal to, how can we calculate? By knowing the value of lambda mc by lambda m infinity. Both we can calculate from Kohlraush formula. Okay, why? Because this is actually concentration only now. So any concentration you can get it in the plotting the graph. That is what we have written as lambda m concentration, and lambda m infinity we need to find out. Look at here. So we actually degree of dissociation of a weak electrolyte we cannot find. If we cannot find out means what we are going with this Kohlraush formula. I said actually speaking, for a strong electrolyte it is going to be 100%. But it is only for strong electrolyte, but not for weak electrolyte. That means we need to find out the percentage only. So that percentage only we call it as alpha C here. So with that only we are going to find out the degree of dissociations. Okay, that is denoted by, degree of dissociation is denoted by alpha C. Lambda mc is equal to molar conductivity at concentration C. Molar, in the same way, lambda m infinity is equal to molar conductivity at infinite dilution. That means this is also, lambda C is equal to degree of dissociation of a weak electrolyte at concentration C. So just knowing the value lambda mc, okay, we introduce the value over here. Lambda alpha C is equal to lambda mc by, we know the lambda m infinity of acetic acid only, right? That means we have to CH3COOH gives you CH3COO minus and H plus only. That means 1 ion only. Just writing down its what is that formula? V plus infinity into lambda plus infinity. That is your whatever the ion, cation and anion, plus anion's molar conductivity and its number of ions. So V minus infinity into lambda minus infinity. So that you get the value of lambda m. That is, you will get that lambda mc and the lambda m infinity. Both you will find out from the formula of Kohlraush. Now you are getting the alpha c here. So alpha c can be calculated by knowing this formula. Is it clear? So please note down that this is the formula. You have to be very clear with the formula, and then application only. So you are just knowing down the, you are finding out the formula from Kohlraush. Okay, that Kohlraush law application is brought over here. Okay, so lambda mc and lambda m infinity can be got from Kohlraush law. So applied here and you are getting the value. Last we are going with the determination of ionization constant of a weak electrolyte. It is nothing but, it is at the equilibrium. It is at a constant. It is nothing but degree of dissociation constant only. Depend upon the equilibrium. That is called ionization constant. Okay. Now I am going with there is one degree of dissociation of weak electrolyte. That means we go with a solution. AB gives A plus B minus. Okay. For example, the concentration is going to be C, means the value it would be like C. Okay. At equilibrium it would be C minus of C alpha. That C alpha ions are transferred to this side, means C minus C alpha. That I can write it as C into 1 minus alpha. Then A plus is equal to C alpha, B minus is equal to C alpha. So I know the number of ions formed over here now. Just introduce into this ionization constant. What is ionization constant? How do we write down? K is equal to, it is nothing but equilibrium constant. Like, okay, equilibrium constant, how do you do? The product concentration of product upon concentration of reactant. The same way, this is the equation, right? So concentration of the product is, concentration of product is equal to, this is, that is concentration of A plus into concentration of B minus by concentration of AB. So K is equal to concentration of A plus into concentration of B minus by concentration of AB. This we have found out. Okay, with this we are going to apply this alpha here, over here, because the value I know, A plus value is C alpha, B minus value is C alpha, and I know the AB value also, that is C into 1 minus alpha. C into 1 minus alpha. I know the alpha is actually equal to, what is that? I got it from the previous one. Otherwise I have written down here for you. Alpha is equal to lambda mc by lambda m infinity. Just introduce that value over here in alpha. Wherever the alpha comes, you just bring down that. Okay. So now the equation becomes C square into alpha square. C alpha into C alpha is equal to C square into alpha square by C minus C into 1 minus alpha. Then what I do, this square and 1C is cut. Okay. This 1C and this down C is cut. So what happens? C alpha square by 1 minus alpha. So substitute that alpha value over here. So alpha value is this, I told you already. So bring it down here. C into lambda m C into lambda m alpha. That is C into lambda m C by, I have to put by over here. That is S slash over here. Okay. Lambda m C. It is alpha square, no? C into lambda m C by lambda m alpha, the whole square. Actually the whole square. Okay. Whole square by 1 minus lambda m C by lambda m alpha. Lambda m C by lambda m alpha. Okay. So when you are getting so, this can be what you are going to do. You are going to take the LCM of this. When you do that LCM, when you calculate the LCM, the final answer what you are going to get is, for this ionization constant is this. That is K is equal to C into lambda m C square by lambda m infinity into lambda m infinity minus of lambda m C. So this is the final formula of K. The K is actually ionization constant. So to find out this Kohlrausch law is helpful to find out, or I write down, I conclude that to determine 3 different things. What are they? One is, I can say, to find out the molar conductance at infinity of a weak electrolyte. Okay. Of weak electrolytes. Okay. Next, number 2, it is easy to, or it is applied to find out the degree of dissociation. Okay. Degree of dissociation of weak electrolytes. Again, last one, it is helpful to determine the ionization constant. Ionization constant of, again, weak electrolytes. Of weak electrolytes. Is it clear? So you have learnt the application of Kohlrausch law. Please go through this, children, and you have to put it in your comment box if you have any queries. Okay. Whatever the topic you want to deal with, please put again in the comment box. I will do for you in my videos. For forthcoming videos, I will definitely finish it off. Whatever that queries you are going to ask for. Okay. Thank you, children. Thank you.